Hi everyone. Thank you so much for the instruction. Today, my topic is on like a secure development of Hugging Face models in trusted execution environments using evidence API and confidential AI loader. So the Ken Lu 若梦浩成董米伟谢夏东 and 周磊 like also contribute to this work. Thank you everyone so much to make this project work. So for today's agenda, firstly, I'm going to talk about the threat model in large language models. And while protecting these large language models, we find that there are some missing part in the current TE open source ecosystem. And then we introduce the confidential Gen AI loader, which will fix the missing part of the current ecosystem challenge. And then while building this loader, we found that there are some challenges to enable the end-to-end trust chain for attestation. Then we introduce our evidence API and container management to bridge the gap for the challenge. Afterwards, we'll show the demo, and you can see how easy it will work to get the confidential Gen AI loader work. And then we'll make some call to actions for us for people to want to join the community. So let me get started. So let's talk about a threat model, which is a well-known problem in everyone who actually supports large language models in production. While we are trying to development the large language models for the training and inference, especially a fine-tuning stage, we found there are lots of threats through use evasion, model theft of the model, and we found that people will intrusively doing model poisoning directly or through the supply chain. We found during the runtime, during the fine-tuning stage, there are some happening on some bad things happening on a runtime model theft and runtime modeling poisoning, and which in return actually requires us to train the model in a confidential way, and also constrain the behavior of the execution of the model to protect the integrity, property, and while ensuring the availability and all the input confidentiality includes the model itself and also the prompt and the input to the RAG system. So how could we resolve that? Previously, the Intel, NVIDIA, and cloud service providers like us actually have already built something like a TEE system, which is the trust execution environment. The TEE system actually ensures that data in use are all encrypted. And however, the system itself not includes as a cloud infrastructure. It not only includes the compute in the memory, but it also includes the attached disk, also includes input and output IOs. So how could to protect the data at rest, we previously with Intel supports one solution, which is called full disk encryption, which you could find on the CC API org as well. And we previously introduced it, which enables encrypting inactive data when stored in a blob storage. However, there's still a missing link. What is missing? So the data in transit in encryption previously, people use different encryption protocols, and however, to enable different encryption protocols, even a network protocol or user space protocols, and the people put it separately. How to enable integrate the data in transit and data in use together is still something hanging there and missing there. in the trusted execution environment, like open source ecosystem. So today we introduce like confidential model loader, which actually integrates the like encryption for like storage and encryption for the like data in transit to make it work together with a TEE environment. So how could people actually using this system? So this system is built with two stages. One stage is like AI model pre-processing, and the other stage is the runtime, where you get the like a confidential loader flow, where you actually load the model and doing the code, doing the attestation for two stages, binary like attestation, and then load the model and get it executed. So during the AI pre-processing stage, like a user will like load AI model and with the key together onto the system. So the AI model will be encrypted by the key and loaded on the model server by the end user. For example, load the encrypted model on the Hugging Face. And on the other hand, the user could choose whatever like KMS, or they could choose our key broker service to register their key. So the and in the runtime, the key where we registered is a key management service. It will attest the key broker service in our TE runtime environment. And our TE runtime environment will in another way attest the key management service. So both parties will ensure each other are in a trusted mode. Afterwards, the key management service will send the key to the like a runtime of in the confidential AI loader, and where the confidential AI loader will catch load the encrypted model from the Hugging Face client, and then use the key to decrypt and prepare the model. And in the end, we run the model as a Hugging Face project. So in this way, there are some missing something still missing in like in the current customer like industry standardized like open source communities for the user space attestation. So our like work actually bridge the gap where we could enable the attestation for user space, where the encrypted data and code and the running code are all like could be attested to ensure the end-to-end like security. So our like attestation includes like several stages. Our enables full trusted chain to using the TE TCB to attest the firmware TCB. Then the firmware TCB enables the OS TCB. Then we bridge the gap of the OS TCB to cluster TCB, and we also bridge the gap between cluster TCB to container TCB. Where using container integrity measurement like an agent, you could attest the workload in the containers. So we actually enables like testing the workload in like 5 different deployments, which actually fits all the deployment style in the cloud. We provide like a support for confidential VM attestation, confidential VM with containerized app. We support confidential cluster, we support confidential container, and we support confidential VM by KubeVirt. So the confidential AI GC loader actually protects the model protection and data protection through the AI model encryption and decrypt model with attestation. So how to use it? Firstly, like user will do the pre-processing where they generate the key, which is the AES GCM key, and then they please encrypt the AI model by the key using the below like script. Then you can upload the encrypted model to the model server. And afterwards, on the other hand, you will like register key to the key broker service, and the key broker service will communicate with the key management service to store the key in its database. So like where you firstly get an access token and then create a key transfer policy, and then register the policy. After register policy, you will need to register the key. So in the build stage, you could use our like build script to run the like a confidential Hugging Face runner to build the container. When you run it in the runtime, you can like see like we'll firstly get a key, and while getting the key, we'll do like a two-side attestation. After doing the two-side attestation, we'll use the key to decrypt the model and then get it running. So here, welcome to like a contribute effort to like CC API community for like enabling it for more like hardware architectures. For example, for Intel, AMD, and ARM, and also we want to like collaborate with like NVIDIA more for enabling like multiple GPU in the future.